Good morning, folks. Today we're going to cover the 20s. We're going to tell you a little bit of information that's going to help you with the back of the next worksheet, which is Squidward, which will be your homework for the next day. Directly proportional or direct relationships must go through 0, 0 on a graph, known as the origin on a graph. And when one variable goes up by, let's say, 3, the other variable goes up by 3 as well. If one doubles, the other doubles. Whatever one variable does, the other variable does. Inversely proportional relationships or inverse relationships mathematically end up being curves on a graph. Whatever one variable does, the opposite happens to the other variable. So if one variable is doubled, the other variable is cut in half. If one variable is tripled, the other variable is divided by 3. So we're going to start off with looking at these relationships. So pressure goes up. What do you think is going to happen to volume? Pause it and see if you can put an arrow that you think is going to happen to volume. Volume will go down. That's known as an inverse relationship. If pressure goes up, therefore volume must go down. When those two are multiplied together, you always get a constant. And the graph of this would look like this. So as volume goes down, pressure goes up. As temperature goes up, what do you think happens to volume? Pause it and put an arrow in. If temperature goes up, volume goes up. So that happens in a hot air balloon. As the temperature inside the hot air balloon goes up, as molecules move faster, they move further apart, they occupy more space or more volume. In this instance, this relationship always gives you a constant. And since as one goes up, the other one goes up by the same amount, this is a direct relationship. As temperature goes up, what do you think happens to pressure? Well, pressure goes up as well. Both of these are direct relationships. So in this instance, P divided by T is a constant. And again, this is another direct relationship. So they both go through the origin. So that'll sum it up. Pause it there if you need to write down more information. So is this a direct relationship? Nope. It doesn't go through 0, 0. Is this a direct relationship? Nope, because 0 is not over there. Is this a direct relationship? Yes, it is. As one goes up, the other one goes up, and it goes through the origin. These are steps that we're going to use for solving the next few problems. This first problem we're going to completely skip. It made more sense to teach it in class, but probably not online. So we're going to go right to this problem. We're going to follow the instructions, and we're going to solve the problem. The very first step on the instructions on the front page say convert all temperatures to Kelvin temperatures in the problem. And Kelvin temperatures, this is on your cover as well, Kelvin temperatures equal to Celsius temperature plus 273.15. So that's what we have to do. So we have a temperature right here of 22.22. So we take 22.22 plus 273.15. Do that math, and we end up getting 7 and 3 and a 5 and a 9 and a 2 and a 295.37 Kelvin. So in the problem, we cross out this 22.22 and we write 295.37 Kelvin in its place. You can probably do that a lot better on your own paper. We have to also convert this negative 10, so we're going to use the exact same formula. And in this instance, this would end up being 262.7 Kelvin. That one you got to watch the sig figs on. Your answer can be no more precise than the least precise piece of data. And 10.5 goes to the tens place, so our answer could only go to the tens place. So I'm going to erase all this because I'm going to need this space for work. So we just did step 1. Step 2 says that we should fill in the data table. So this is our initial temperature, 295.37 Kelvin. And we're going to go to 262.7 Kelvin. So we're sticking this balloon in the freezer, and we want to know what's going to happen to its volume. The initial volume of the balloon is this, so I'll write that in. And we're trying to figure out what the final volume in the balloon will be. So I can see in my problem that my temperature is going right here, going down. And if temperature goes down, then volume should go down. We learned on the previous page, only pressure and volume are opposites of each other. Everything else is a direct relationship. So if one goes up, the other goes up. So I follow the steps. I just did step 2. I look at step 3. It says look at your variable pressure volume and find the variable that only has one piece of data. In other words, I'm looking at this data and which piece of data doesn't have a partner, and that is the milliliters. So that's what I'm going to start with. The next step says put a multiplication sign and a division bar. The next step says look at the other variables that do have partners and put that label on top. So I put Kelvin on top because those have partners. Number 6 says, how does the variable change in the problem? Below each factor, abbreviate the variable and assign an arrow up or down. This is not optional. So in this problem, I have temperature and I have volume. In the problem up here, we said that the temperature is going down. So temperature is going down, and so that should make my volume go down. So I need to arrange these two numbers right here in a way to make this volume right here get smaller when it goes as your final answer. So if I want my answer to get smaller, I put the smaller of the two numbers on top. Want your answer to get larger, put the larger of the two answers on top. If we look at this part right here, you take a small number divided by a big number, you're going to get a number less than 1. And when it's multiplied by this number, it should give you an answer smaller than 1. If you would put this big number on top and a small number on the bottom, you're going to get a number greater than 1. And then when you multiply it by this 3552, it should give you a number greater than 3552. So now I do the multiplication. So the k's cancel out. We're left with a label of milliliters. And our final answer ends up being 3159 milliliters. Pause the video at any point in time. All right, we're going to do sample 3. Why don't you give it a shot first before I go over it by simply pausing the video. It says, note that pressures come in millimeters of mercury, inches of mercury, atmospheres, torr, and psi. Don't let that freak you out when you see different pressures. For some reason, there's just a whole bunch of different ways of labeling pressures. It says you tie a rock to a balloon full of air, you throw it into a lake. What will the volume of the balloon be when it hits the bottom of the lake? Will it increase, decrease, or stay the same? Pause the video, give it a shot, see what you think. Well, its volume will, in fact, go down. It says the balloon contains 3.55 liters of air, so that's my initial volume. It says at room temperature, which is 21 degrees Celsius. So again, I take 273.15 plus this 21.00. And I cross out the Celsius temperature and I write that in above it, 294.15 Kelvin. You don't have to show this work anywhere. It's fine for you to do that on a calculator. So I had a temperature of 294.15 and atmospheric pressure of 762 millimeters of mercury. It says the balloon falls to the bottom of the lake where the temperature is 10.15. So 10.15 would be 283.30 Kelvin. Cross that out, so that's where it's going to go to, 283.30 0.30 Kelvin. And it says the pressure is going to go to 1624 millimeters of mercury. So in this problem, it wants us to calculate the final volume. So right here, our temperature is going down. Temperature goes down, volume should go down. In this problem, our pressure is going up. If pressure goes up, then volume should go down. So both of those variables are going to make it go down. So I look at all those pieces of data. I find the piece of data that doesn't have a label partner, and that is volume. 3.55 liters, multiplication sign, division bar. Feel free to stop this at any point in time. I look for labels that do have partners, and I put one of them on top, so millimeters of mercury. I also could have done Kelvin as well right away if I wished to. I look at just the pressure. The pressure in this problem is in fact going up. If pressure goes up, then volume should go down. So I need to arrange my two pressure numbers so that the volume right here will become smaller when it comes out this other side. So if I want my answer to get smaller, I put the smaller of the two numbers on top. Now I pretend like this part of the problem doesn't exist, and I do a multiplication sign, and I do the problem a little bit further. Now I'm going to look at the Kelvin, because it's another pair that is in the problem. So here, temperature is going down, so volume should go down. So I need to arrange those two to make that initial volume right here become smaller. So I put the smaller of the two numbers on top. The K's will cancel out, the millimeters of mercury will cancel out. We're left with our label of liters. And go ahead and crunch that number, see if you get the correct sig figs. The answer ends up being 1.60 liters. Now in this next problem, you're going to find out that one of the variables is going to make the temperature go up, and one's going to make the temperature go down, and that is fine. When you solve the next problem, the answer ends up being 221 Kelvin, so you're going to go ahead and give that a shot and see if you can set it up correctly to get that proper answer. And when you have to eventually convert it over to Celsius, remember it's 273.15 plus the Celsius temperature equals the Kelvin temperature. So you're going to plug that number right in there, do a little reorganization to calculate the Celsius temperature, and if you do that correct, you get negative 52 degrees Celsius. Your homework is Squidward, which is the next page. Go ahead, see what you can do. A couple things that I do want to point out, and go back to the last problem real quick. These arrows are mandatory. You must do the arrows underneath each factor. But these data tables will eventually disappear, and it is your choice if you decide to continue on with the data tables. So in some problems it might say if, and that's where you put this pressure part, then the volume will do what? So you might see that on some of the problems. Don't get freaked out by that. Hope that helps. Have a good day. Come on in for help if you need more help.